The engines powering today's AI data centers weren't invented by an engineer. They were built by a 19th century grocery salesman. While the establishment chased steady steam pressure, Nicolaus Otto saw power differently. Controlled detonation, violent, discontinuous, shocks. In 1876, he cracked the four-stroke cycle, layering dead exhaust gas to cushion the blast so the iron block wouldn't shatter. That engine was just the opening act. What followed was a ruthless century. Deutz sparked a global era, alienated legends like Gottlieb Daimler, survived a blood-stained history of wartime forced labor, and clawed back from the brink to rule the modern world. Let's back up. The origin of Deutz is the origin of the internal combustion world. The man behind the iron was Nicolaus Otto. He spent years on the road as a traveling grocery salesman, watching small shop owners get crushed by the cost of steam. Steam engines needed a full-time crew, a dedicated brick building, and deep pockets. If you didn't have all three, you were stuck. Otto wasn't a trained engineer. That turned out to be his greatest asset. He didn't think about power like the establishment, who only saw continuous pressure, a steady 24/7 push from a coal-fired boiler. Otto pictured power as a series of sharp, explosive hits, controlled detonation, violent, discontinuous shocks. That mental shift changed everything. Otto and his partner, Eugen Langen, founded the factory that would soon take the name of its Cologne suburb, Deutz, and together they built the atmospheric gas engine. Picture a vertical iron tower standing 10 to 13 feet tall. Inside the cylinder sat a heavy free piston, weighing around 80 pounds on the half-horse block, connected to the output shaft through a specialized Rouleau-Langen freewheeling clutch. That meant the piston was completely unloaded on the way up. The gas charge fired. That massive piston shot upward with nothing holding it back. The clutch disengaged, saving the shaft from the violent shock, ultimately wringing a measly 3 horsepower out of a machine the size of a telephone pole. All the usable work happened on the downstroke. Atmospheric pressure slammed the piston back down against the vacuum left by the cooling gas. And the ignition? No spark plug, and sure as hell no glow plug. It wasn't burning liquid fuel yet, just a live, hissing open flame fed by raw illuminating gas, piped right off the city streetlights, sitting next to the intake port. The engineering establishment said it would shake itself apart under load. They were wrong. It held together long enough to take the gold medal at the 1867 Paris World Exposition, beating out 14 competing gas engine designs. The judges didn't just like the mechanics. The numbers settled the debate. The Otto Langen engine burned less than half the gas of the French-built Lenoir engines. That wasn't a marginal tweak. That was proof the thermodynamics were in a completely different league, putting the Deutz name on the map. That tower was just the opening act. Otto spent the next decade chasing the 4-stroke cycle. When he cracked it in 1876, he rolled out the Otto silent engine. Intake, compression, power, exhaust. 4 strokes of the piston, 1 power event for every 2 rotations of the crankshaft. It sounds simple now, but no one had made it work reliably at scale. The secret was Otto's stratified charge concept. He layered dead exhaust gases near the piston crown before ignition. They called it silent because that inert exhaust buffer turned what used to be a shattering, deafening detonation into a heavy, sustained push. It kept the block from blowing apart. That combustion event was shaped, not just triggered. Pair that with Otto's slide valve flame ignition, and you finally had a viable product. It still relied on a pilot flame, but the burn was isolated inside the valve and timed dead on to the compression stroke. Reliable, repeatable. Deutz didn't just build engines after that. Deutz owned the patent on the 4-stroke cycle. Anyone wanting to build one had to pay Deutz first. Their factory in Cologne became the first dedicated engine manufacturing plant on Earth. They were shipping heavy iron to Britain, France, Austria, and the US while competitors were still arguing over steam. Steam was dead. Deutz pulled the trigger. Running an operation like that at a wide-open throttle requires serious talent, and Deutz hired the best. Gottlieb Daimler took over as the technical director, bringing in Wilhelm Maybach as chief designer. They were the kind of engineers who solved problems before the rest of the world knew they existed. Together, they pushed Deutz's engine designs forward faster than management could handle. That's where the rot started. The suits running Deutz weren't stupid. They built a global empire from scratch, but they were managing a cash cow. The last thing a board wants is top engineers demanding a total rebuild. Daimler kept pushing for lighter, faster, high RPM engines. He wanted blocks that could power moving vehicles, not just iron bolted to a concrete floor. The board saw only risk. They wanted to protect their royalty checks and keep the assembly line quiet. So, they pushed Daimler out. Maybach followed him. Just like that, Deutz walked two of the greatest mechanical minds of the 19th century out the front door. Cologne never fully recovered from what happened next. Daimler and Maybach set up their own shop, bolted Maybach's new surface carburetor to the block so it could finally burn liquid fuel, and built a high-speed engine that could actually power a moving chassis. They eventually founded the company we now call Mercedes-Benz. That was Deutz's top talent, running free to build the Titan. And it gets worse. By 1884, Deutz had finally ditched the pilot flame and developed a low-voltage magneto to fire the cylinders with an electrical spark. It was a massive leap forward, but they dropped the ball again. A young engineer named Robert Bosch studied that very magneto and improved it in ways Deutz ignored. Deutz used heavy bar magnets. Bosch swapped them for U-shaped magnets, shedding enough weight to survive 1,000 RPM in a moving chassis. He built Robert Bosch GmbH into the multi-billion-dollar juggernaut sitting inside your truck today. Deutz's intellectual property walked right out the door in the heads of the men they refused to listen to. Then the courts finished the job. In 1886, a German judge invalidated Otto's foundational four-stroke patent. The smoking gun? A theoretical pamphlet written in 1862 by a French engineer named Alphonse Beau de Rochas. No working machine, no blueprints, just words on paper that nobody had ever built. With one ruling, Deutz's licensing monopoly collapsed overnight. Every competitor stopped paying royalties. The market blew wide open. Deutz went from owning the table to fighting for a seat at it. As the 1880s closed out, Deutz still had heavy manufacturing, real engineering chops, and the momentum to stay in the fight. The monopoly was dead, their best engineers were gone, and the rival companies they built were pulling ahead. Daimler and Maybach were out in the Stuttgart workshop, bolting an engine to a carriage frame. The iron they forged would power the first trucks, and a new kind of mechanized warfare nobody in 1890 could even picture. Deutz built those men, funded their early work, and threw them out for asking hard questions. The fast-approaching 20th century was going to demand answers to much harder questions than that. The 20th century didn't wait for anyone, and Deutz walked into it still bleeding. Right on cue, Rudolf Diesel knocked on their door with his compression ignition concept, the exact tech that now powers every semi and excavator you wrench on. Remember, Deutz was founded by Nicolaus Otto, the guy who literally invented the four-stroke cycle. They were already kings of the gas engine, so when Diesel showed up, they figured his high compression idea wasn't worth the headache. Diesel took his engine to MAN, and another empire was built on Deutz's missed opportunity. In 1908, Deutz engineer Prosper L'Orange developed an early split combustion chamber right on the Cologne floor. The suits passed again. L'Orange walked, took his ideas to Benz, and filed the defining pre-combustion patent in 1909 that shaped diesel injection for decades. Meanwhile, a young Ettore Bugatti worked days at Deutz while secretly building a lightweight, high-performance chassis in a Mülheim basement. He hid it because management wanted 12-liter luxury tanks for the wealthy. Bugatti knew better. He filed his own patent in 1909 and left to found a legend. 4 world-class engineering minds walked through Deutz's doors. 4 times, leadership ignored the gold sitting right under their noses. Deutz didn't fold. They went where other builders wouldn't. Underground. In 1896, Deutz built the first internal combustion mine locomotive. To understand the impact, look at what it replaced. Pit ponies. Blind horses living their whole lives underground, dragging coal cars through choking tunnels too tight for a grown man to stand in. The air was thick with soot, coal dust, and methane. One spark meant death. Deutz built a compressed charge engine with a water bath exhaust scrubber. It dropped exhaust temperatures below 171 degrees Fahrenheit, killing the risk of methane ignition. It was small, low, and built to move heavy tonnage through the dark without blowing the mine to pieces. It replaced the horses, the feed bills, and the slow, blind deaths. When World War I hit, Deutz went all in. While rival heavyweights like MAN and steel giant Krupp built the towering diesels that shoved Kaiser Wilhelm's U-boats through the Atlantic, Deutz hammered out massive six-cylinder marine engines and generators to keep the rest of the Imperial Navy moving. On the other end of the scale, Motorenfabrik Oberursel, a heavy-hitting company Deutz would swallow up just a few years later, built the UR-2 rotary engine for German fighter planes. It ran a total loss lubrication system that continuously sprayed castor oil through the cylinders, out the exhaust, and right into the pilots' faces. Castor oil is a natural laxative. The Red Baron and his men flew combat missions soaked in the grease, fighting off intestinal chaos while trying not to die at 12,000 feet. Between massive marine blocks pounding through water and Oberursel's rotary engines screaming at 12,000 feet, the foundation for a global war machine was laid. In the 1930s, Deutz merged with Magirus, a fire engine builder from Ulm. They took the 528-foot Ulm Cathedral spire as their logo. It wasn't an accident. It signaled exactly what the company was: built to last, towering, impossible to ignore. Magirus Deutz trucks became the European workhorses, stamping that cathedral logo onto fire engines and heavy equipment worldwide. Then came World War II. There's no clean way to talk about this. The ruling regime tapped Deutz's parent company, Kleckner Humboldt Deutz, as a model enterprise, giving KHD priority steel in exchange for total integration into the war machine. By 1944, Deutz mass-produced air-cooled diesels because the German military needed power plants that cold-started in the freezing Russian mud. Liquid-cooled blocks were cracking. Air-cooled iron survived. Deutz built the Rappenschlepper Ost, a tracked artillery tractor. They dropped in the F4L 514, a massive four-cylinder air-cooled diesel hammering out around 70 horsepower, built specifically for the Eastern Front, where wheeled rigs sank in the mud. Wide tracks, high clearance, and an air-cooled engine. The RSO worked. It hauled artillery across frozen hellscapes that shattered other gear. It was also built by forced labor. Men and women dragged from occupied territories and prison camps assembled these engines. When the Cologne factory burned from relentless Allied bombing runs starting in 1942, production was simply shoved into underground bunkers. Deutz built war machines while their roof caved in, and the hands turning the wrenches were captive laborers. That is the grim reality. Engineering brilliance doesn't wipe away forced labor. Both sit on the exact same ledger. When the Allies captured German equipment across Europe, mechanics didn't scrap the Deutz engines. They stripped them down. In sub-zero freezes that cracked conventional blocks overnight, Deutz iron kept hammering. No coolant to freeze, no radiator to take shrapnel, no water pump seal to blow 200 miles from the nearest supply line. Allied engineers wrote detailed reports on the cooling fin geometry and direct airflow paths. They had to know how Deutz solved the exact heat problem killing Allied gear every single day. The Cologne factory ended the war as rubble, but the design files and the men who understood those air-cooled cylinders survived. You can bomb a building. You can't bomb proven engineering principles out of existence. Rebuilding in the late 1940s, Deutz started from scratch on the building, not the tech. A leveled factory is just a construction gig. Lost engineering is a decade you never get back. Deutz had their core team and the Allied reports proving their air-cooled design was the toughest block on Earth. That rebuild birthed a line of diesels that powered Rhine River barges, South American tractors, and military rigs across 3 continents. If you've ever stood next to one of these post-war air-cooled blocks pulling a heavy load, you know it sounded like a coffee can full of bolts. A deafening, rattling howl that told you that massive cooling fan was doing its job. No water, no coolant, no excuses, just raw iron, cooling fins, and the load you bolted to it. They refused to die when everything else choked, and the global market bought in fast. By the 1950s and 60s, Deutz's rebuilt Cologne works shipped iron the rest of the industry couldn't touch. The FL 912 and 913 series didn't just put Deutz back on the map. They rewrote what a diesel could survive, completely eliminating the risk of a freeze. Just finned cylinders, rushing air, and raw compression. The secret to that ruggedness was the individual cylinder jug design. Each cylinder bolted to the block separately. If a piston cracked, you didn't pull the whole engine. You snapped off that single jug, swapped the piston, and had it roaring again in 2 hours, right in the chassis. That feature alone was worth more than any printed warranty. However, all that raw thermal expansion had a cost. Those individual jugs stretched and shrank so violently that the pushrod tube seals constantly wept. A Deutz was always going to mark its territory with a fresh puddle of 15W40. The brilliance of air cooling becomes obvious when you look at the alternative. Water-cooled blocks are a fragile balancing act. They need their coolant kept between 180 and 200 degrees Fahrenheit. Too cold, you get incomplete combustion, raw fuel washing the cylinder walls, and oily sludge. Too hot, head gaskets pop, coolant boils into steam, and you're done. Air-cooled engines skip that game entirely. Heavy fins pull heat straight off the iron cylinder walls and dump it into the roaring airstream. Sitting in 110-degree Istanbul traffic for 20 minutes with a heavy load, the FL912 kept thumping. Down in the Antarctic at negative 40 degrees Fahrenheit, crews cranked Deutz generators with no block heaters. The iron just fired up and ran. You can't print a brochure that beats that kind of field performance. The Soviet Union proved it on a massive scale. Under Project Delta, the USSR bought 9,500 Magirus Deutz V-Series trucks in the early 1970s. Operators called them the Bulls of Ulm. Under the hoods of those rigs were the legendary 413 series engines, massive, naturally aspirated V8s and V10s cranking out over 600 pound-feet of torque in conditions that turned regular coolant into solid ice. The Soviets needed them for Siberian pipeline construction, where winter slammed down to negative 76 degrees Fahrenheit. At that extreme, water-cooled engines weren't just struggling, they were cracking their own blocks in half. The Deutz air-cooled iron cold-started and dragged heavy pipe across frozen mud that destroyed the rest of the Soviet motor pool. Good engineering doesn't care about Cold War ideology. It just works. Deutz also forged a massive joint venture with Fiat to help create the Iveco brand, putting their iron on commercial trucks rolling across every major highway in Europe. Stateside, their compact diesels became the beating heart of Bobcat skid steers through the 80s and 90s. If you've ever run one, you know the idol, a dry metallic clatter that sounds like it's rattling itself apart, but never actually breaks a sweat. Over that clatter, you hear the signature screaming whine of the massive axial cooling fan up front. Lose the belt on that fan, and it's about the only way you'll ever melt down one of those blocks. That was the peak. Bulletproof iron and a century of hard engineering firing on all cylinders. That is exactly when the suits upstairs started making decisions. In 1985, Deutz bought the ag division of American tractor legend Allis-Chalmers, rebranded it Deutz Alice, and sprayed every tractor spring green. It looked like a boardroom focus group, not farm machinery. Guys who grew up on deep Persian orange iron walked into dealerships, took one look, and walked out. Farm loyalty is forged in blood and grease. Deutz blew up that trust for brand consolidation, and the market slammed its wallet shut. It got worse. The same air-cooled engines that conquered Siberia were a freezing disaster in a Midwest January. Liquid-cooled blocks heat the tractor cab using hot coolant. Air-cooled engines don't have that loop. They tried to heat those cabs using engine oil heat exchangers. On a 10-degree morning, it blew lukewarm air at best. Worse, if a seal cracked, you spent your shift choking on the smell of burnt motor oil. In a bitter Minnesota winter, farmers sat shivering in freezing cabs. The field started calling them kraut cans, and the name stuck. Sales tanked. Dealerships fractured. Warranty claims piled up because slapping Deutz engines into legacy Allis-Chalmers frames caused ugly fitment and cooling issues neither engineering team had worked out. The acquisition became a massive money pit, dragging the whole company to the edge of bankruptcy. By 1995, the frame cracked. Deutsche Bank forced a bailout with heavy strings attached. Deutz had to sell off the entire Deutz Fahr agricultural division. Tractors, combines, the whole farm empire they'd spent years and hundreds of millions of German marks building, just gone. Scrapped just to keep the core engine lines breathing. That's not corporate restructuring. That's amputation without a tourniquet to stop the bleeding. Overnight, Deutz went from a heavy industrial powerhouse to a stripped-down engine supplier with a terrifying balance sheet. In 1998, Swedish truck giant Volvo bought a massive stake, injecting cold cash that finally gave Deutz room to breathe. On paper, it was the perfect rescue. stable money, and a heavy-duty industrial partner. It might have worked too, except the EPA and European regulators started dropping tier emission standards that choked the entire diesel world. These new regulations declared an absolute war on nitrogen oxides, or NOx. Here's the brutal reality of physics. Nitrogen oxides, NOx, spike when combustion burns too hot or unevenly. To control NOx, you have to lock the combustion chamber temperatures inside a tight band. Liquid cooling gives you exact temperature control for emissions, but with air cooling, the front cylinder stays freezing while the back cylinder bakes. That massive temperature spread isn't a design flaw you could fix with a bigger fan, it's just the physics of blowing air across hot iron. Uneven temperatures mean uneven combustion, which means wild NOx output. You blow right past the EPA's thermal window, you fail emissions. Full stop. Deutz ran the numbers. The answer was grim. 50 years of air-cooled heritage couldn't beat the new standards. A redesign would cost as much as starting from scratch. So, they scrapped the legacy. The new TCD series took over, liquid-cooled, common rail, and engineered from the oil pan up to pass Tier 3 and Tier 4 final emissions. The air-cooled era didn't end with a catastrophic field failure or blown engines. It died against a regulatory wall and the stubborn physics of heat transfer. Deutz killed their most legendary iron because the alternative was going out of business. The TCD engines kept Deutz in the fight with a compliant block for the 2000s. Surviving the emissions purge just kept them treading water. The 2010s brought an entirely new threat. Battery electrics started siphoning billions away from diesel R&D. The same equipment builders who relied on Deutz started wondering if they even needed a combustion engine supplier at all. Deutz didn't fold. They ran the numbers and made a cold-eyed call based on raw physics. The 2010's EV pitch sounded clean. Quiet motors, zero emissions. Every OEM chased it. Deutz didn't want to get left behind, so they bought Torqeedo, an electric marine motor outfit to plant a flag in the battery space. On paper, it was a smart hedge, but out in the heavy-duty industrial world, it slammed into a wall of physics no press release could fix. Batteries don't scale for heavy machinery. That's a load calculation, not a debate. Matching the energy density of a 100-gallon diesel tank with lithium drops nearly 40,000 pounds of dead weight onto an excavator. The machine couldn't lift itself, let alone a bucket of rock. A job site diesel generator screams at high demand load for 14 hours straight. No battery touches the energy-to-weight ratio of diesel. You can charge an electric mini excavator overnight to dig dirt for 3 hours. Try running a 500 kilowatt backup on batteries through a 72-hour grid outage. The math fails. Torqeedo built fine motors for ski boats and light harbor duty, but toys weren't going to fund an industrial pivot. It burned cash and hit a dead end. The EV detour failed, forcing Deutz to pivot back to what they actually knew: heavy, unstoppable combustion. Deutz sold it, took the hit, and moved on. Panic wasn't the plan. CEO Dr. Sebastian C. Schulte rolled out the Dual Plus. It ran on hard physics. Schulte bet battery tech wouldn't scale fast enough to replace heavy diesel before Deutz ran out of time. Instead of following the EV crowd off a cliff, Deutz locked in cash from their combustion service network, cut the fat, and bankrolled a parallel push into hydrogen. The China play was calculated. Deutz signed a joint venture with Chinese heavy equipment giant SANY to build domestic engines. China's infrastructure boom demanded reliable diesel in staggering volume, and SANY needed a partner with emissions-compliant tech. Their Changsha plant rolls an engine off the line every 6.5 minutes at 90% automation. Deutz didn't go for cheap labor. They went for raw production scale Cologne couldn't match. They secured the volume, SANY got certified German engineering, and they pulled this off while Western analysts typed think pieces claiming Chinese EV dominance would kill combustion in a decade. The factory just kept stamping out iron, pumping cash to fund the hydrogen program. That program birthed the TCG 7.8H2. It's a 7.8-liter straight six, kicking out right around 295 horsepower, burning hydrogen instead of diesel. It runs the same four-stroke cycle Deutz has built since the 1870s, but spits near-zero carbon out the stack. No heavy battery pack, no 400-volt charging cables. Just compressed hydrogen, high-pressure injection, and a cast-iron block any seasoned diesel tech can wrench on. Under load, it powers heavy equipment at wide-open throttle, dodging the duty cycle limits that cook battery systems. The iron heart stayed the same, only the fuel changed. To keep hydrogen alive, Deutz needed cash. And here's the punchline. 142 years after the Deutz board chased Gottlieb Daimler and his chief wrench Wilhelm Maybach out the door for pushing too hard, Deutz forged an alliance to market Daimler trucks' heavy-duty blocks off-highway. They didn't stop there. Deutz bought the global sales and service operations for the massive MTU Classic and Series 1000 through 1500 engine platforms straight from Rolls-Royce Power Systems. Deutz pulls high-margin profit on every service call. The company that fired Daimler in the 1880s now gets paid to keep his mechanical descendants roaring. Two massive names in heavy power writing checks to Deutz. They built their 20th century empire on air-cooled diesels that couldn't freeze in Siberia or boil off in the Sahara. They brought that same bulletproof mentality to the modern power grid. That cash funded the acquisitions that rebuilt the company. They bought Firk Aggregatebau, a standby power specialist that catches the load the millisecond a grid drops, and Blue Star Power Systems, a heavy hitter in American backup infrastructure. Those moves slammed Deutz straight into the emergency power market, specifically the roaring generator sets keeping AI data centers alive. A data center can't blink. When the grid hiccups, Firk's generators bark to life, bridging the gap before server racks sense a fault. Deutz projects this energy segment will hit 500 million euros by 2030. All of these strategic pivots paid off. Q1 2026 revenue hit 530 million euros. That wasn't luck. It came from the oldest machine manufacturer on the planet, a company that refused to die through 160 years of wars, patent collapses, and regulatory gut punches. Drive past any massive data center, and you'll find a row of standby generators out back, smelling of diesel and hot exhaust. A lot of them rely on a Deutz block, hammering out the exact same four-stroke cycle Nicolaus Otto cracked in a rented Cologne workshop in 1876. Deutz rarely got the glory. The iron kept running anyway. Deutz didn't win by being the smartest guys in the room. They won by refusing to quit, even while arming their own competition. Every engineer they shoved out the door came back as a rival. When you cross guys like Gottlieb Daimler and Wilhelm Maybach, you just bought yourself a century of headaches. Every lost patent cracked the market wide open. When they lost their monopoly on the four-stroke Otto cycle in 1886, they basically handed the keys to the internal combustion kingdom to the rest of the world. Arrogance isn't fatal, but it's damned expensive. You better have the engineering depth to pay the tab. Deutz paid it in lost patents, alienated talent, and the lives of thousands of forced laborers building their wartime rigs. Ulm's Magirus plant ran on a dedicated subcamp of Dachau, where starving prisoners wrenched together diesel parts in the soot and cold. That's the ledger. Neither side washes the other clean. Today, that same outfit is chasing $4.3 billion a year by 2030. They're doubling their output to power AI data centers and autonomous military robots. Busted your knuckles on an air-cooled 912 or 1011 series? If you've still got ringing in your ears from those screaming cooling fans or spent hours picking oily soot out of the cylinder fins, tell us about it below. Hit subscribe before you clock out. We've got more iron to cover.